Hello, this is Mary Pat Campbell, also known as Meep, which is my high school nickname. In this video, I'm going to talk about some high-level mortality trends through 2022, which is just provisional data at this point. I'm not giving you the entire presentation, just the first few slides from this presentation. I'll be doing subsequent videos, going through other parts of this presentation. There were 70 slides in total. No, I'm not doing the whole thing right now. But because I'm breaking this up into multiple videos, I'm going to actually be able to take time through each of the sections. I was only given 1 hour for the Iowa Actuaries Club, and I deliberately put too many slides in because, hey, we're all actuaries together, and they can look at the data later and ask me questions if they had questions, so they can probably interpret a lot of the data that I had put in there. So first I'm going to start with all-cause mortality trends, and all-cause meaning all causes of death. So I'm going to start at very high level with mortality rates for the entire country of the U.S., and then get down into age groups and other slice and dice over time. And I'm going to start way big, and then we're going to, get really close to the different. So starting way back, the easiest way, and just so you know, it's very small print at the bottom of my slides. In the show notes, I will provide a link to my Dropbox, which has the slides and the various spreadsheets where you can get the data. It originally came from CDC WONDER, which is the database where, they aggregate all the death statistics from the death certificates in the United States. All the death data through 2021 have been finalized. The data for 2022 are still provisional. It takes up to a year, and I'm not getting into the process. I have a whole series called Working with Wonder where I show how you can get the data out of CDC WONDER. Anyway, the data for 2022 are still provisional. Death rates are generally quoted. This was a presentation to an actuarial club, so I'm not doing what I normally do for general audiences, but I will, speak it out because I'm assuming I'm talking to non-actuaries here. The rates are per 100,000. I'm not giving percents here, but I will translate it into percent. So per 100,000. So the 1% level is at 1,000. So this is where 1% sits, is at the 1,000 mark here. And there's 2 lines on this graph. The crude rate, that's the easiest to understand. Crude rate is just number of deaths divided by total population. So this is what you might think of when you think of death rates, and that's this dark blue line. But the issue with the crude death rate is that it's biased because of the aging of society. Back in 1968, the baby boomers, were young. They were little kids. Or my parents, were in high school back in 1968. They graduated in 1970. So high school, that is. So here we go. So what happens is the crude rate is influenced by what the age distribution is, as well as the overall kind of mortality trend for each different age bucket. So this has kind of gone sideways. Then around 2010 or something, it started going up because the baby boomers were getting old. And of course, in the pandemic, it really jumped up. To try to get away from the influence of what the age distribution of the population is, we have something called the age-adjusted death rate. And that's this light blue. Now, what we do with an age-adjusted rate is we're going to take a standard set of weights to try to do a weighted average death rate. So let me just give you a general idea. This is not exactly how it's done, but this is the general idea. So let's say we bucket it up by age group, say like age 15 to 24, 25 to 34, 35 to 44, etc. And then we figure out the crude rate for each of these age buckets, okay? And then we're going to put a weight on each of these, and the weights are going to add up to 100%. We'll do a weighted average across this, and we're going to use the same set of weights for each year or each state or whatever groups that we're trying to compare against. So we'll have a standardized population or standardized weights. We use what's called a 2000 standard population. Now, it's not exactly the age distribution for the year 2000. If it were, then the crude rate and the age-adjusted rate would be exactly the same in the year 2000. It's not. These two lines, and I made them very thick so you could see them very well. But the two lines cross over about the year 2003. So they're not exactly the same. I'm using the same set of weights over these entire lines. The CDC updates these weights about every 30 years. So there's actually a 1940 set of weights, a 1970 set of weights, and there's probably going to be a 2030 set of weights. The reason they're not exactly the same as what was in the year 2000 is there's, a lag between what the Census Bureau does and what the CDC does. So, and this is partly why the death rates for 2022 are provisional, because the death counts for 2022 as of, it's now April 4th, 2023, while I'm recording this. There is a lag in reporting, but, the number of deaths, that's the numerator for our rates, those are pretty solid. But the denominator, which is the population estimates for different age groups and that kind of thing, that comes from the Census Bureau. And, that's usually about mid-year in terms of like July 1st, 2022. And there's a lag in when the Census Bureau comes up with that. I've made my own estimates. We have to estimate these things. So let's zoom in, enhance, and see what was going on from 2018 to 2022. Okay. What you're seeing here, let's look at this horizontal scale. I'm going from 2018 to 2022. Again, the numbers from 2018 to 2021 are finalized. These aren't, the rates here are average number of deaths per day, and this is in the US, all causes. And I did this average deaths per day, so it's not influenced by how many days are in each month. Some people were taking total number of deaths for the month and wondering why you had it go down in February. I'm like, February has 28 days, guys, and March has 31. So, divide by the number of days for the month, so you normalize it, you have average deaths per day, and then you don't have to worry about the number of days per month. Okay, but moving on. So we have it going monthly deaths, it's average deaths per day, and I pushed it back to 2018, partly because the provisional database makes it very easy. It starts in 2018. But I wanted to have the two pre-pandemic years because 2018 has the tail end of a bad flu season, and flu/pneumonia deaths tend to peak in January from the seasonal flu deaths, and it was bad, 2017 to 2018, and 2019 was a boring death year. There's you can see it's just whew. I've looked at many years. I'm not showing you the seasonality of multiple years here. I've looked at lots of these things. And usually there's a little pointy peak in January each year from flu and pneumonia deaths. There's a seasonality to deaths. It's usually old people dying. And there's a lot of flu and pneumonia deaths, but also heart disease has a seasonality too for old people. Interestingly, cancer deaths do not have a seasonality. And it's interesting to see which causes of death have seasonality, which don't. And it's not always winter where the peak is. Unsurprisingly, drowning deaths, for instance, have a seasonality where the peaks are in the summer. Makes sense for the United States. And obviously, if you're in the northern hemisphere versus southern hemisphere, yada, yada. Okay, we're going to move on from that. So that's enough for the pre-pandemic. Let's look at what the pattern during the pandemic was. Remember, this is the entire United States. It's a large country. In a future video, I will be talking about differences between the states. And everyone like, oh, red state, blue state, blah, blah, blah. No, I'm not talking about political stuff. I'm actually talking about geography. Some states are in the north. It gets cold. Some states are in the south that have deserts. There are different kinds of weather patterns in the U.S. It helps to know your geography, guys. A lot of people like to think this is a political thing, but I just came back from the Adirondacks, upstate New York, way upstate, almost in Canada. It snowed on us March 31st. Guys, there are some real differences in weather, and it does have effects with regards to death rates of certain. I just mentioned drowning. Well, you're not going to drown. Well, some people can drown in the middle of Idaho, but you're not going to die of a shark attack in Idaho unless you have some really interesting circumstances. In any case, when we saw this first COVID peak of deaths in April 2020, this was not across the entire United States. It was centered around New York City, and they had a huge spike there. But at the time when I was looking at this, and people were arguing with me, oh, are they COVID deaths, blah, 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 blah. I don't care. Just looking at, this is from all causes of death. New Jersey had a spike. Connecticut had a spike. It's like it was proximity to New York City. There were some increases around New Orleans, Detroit, and Chicago as well. And it wasn't everywhere. There were some things going on the West Coast, but, not so much. New York City was just very hard hit. It did remind me of what happened in, I believe, northern Italy and in Spain when they were getting those first hits of COVID. That was not across the entire U.S. when we had that initial spike. Similarly, the summer wave of COVID deaths in 2020, that was along like the South, Texas, I think Florida as well, some of the Gulf states, Arizona, New Mexico, along there. But those first couple waves, that was not across the entire United States. The reason I keep emphasizing that is because this third peak, that was like, okay, if you didn't get hit in that first or second wave, you got hit bad in that winter wave of 2020 into 2021. And that was a very high peak, and it was everywhere. The rest of the United States, especially in the Midwest and across the North, Midwest, like Minnesota and Wisconsin, all of those places. But, Ohio, Pennsylvania, all over there. If you got missed here and you thought, well, this wasn't affecting us. Well, it was affecting you by this point. Then in spring 2021, it collapsed in terms of COVID deaths. Now, we'll see this in a moment. This is still elevated deaths compared to 2019 and 2018 and prior years. Then at late summer, early fall, now here comes the Delta wave. Woo! And we had a double peak here. Again, there were different geographic patterns across the United States. And that was the last hurrah for really high COVID deaths. It collapsed in spring 2022, just like we saw in spring 2021. And while there have been continuing COVID deaths, and in later videos, I'll be talking about patterns of COVID deaths, and I'll just do one just on COVID by itself. And then I'll do other causes of death as well. And we have a little upswing here, but it's not just COVID, by the way. This is still elevated compared to 2019, 2018, etc. But, it's just kind of flat. We're not seeing a lot of that wave structure that we saw in 2021 and 2020. But, this is, we take a look here. We see these waves, a couple of years of that, and then it's kind of gone flat. What's going on? Let's do a comparison against prior years. And here is my comparison. Before I get into these specific numbers, I want to talk about what I have in this box up here. Percentage change compared to 2019 Average number of deaths per day, U.S., all causes. So why am I saying this and I have all these words? Why am I not saying excess mortality? I'm being a persnickety actuary. So the Society of Actuaries, of which I am a member, has put out research where one of another fellow member, I am a fellow of the Society of Actuaries, has done a research paper where he has looked at a variety of definitions of excess mortality. This one is like just take a prior year or something to compare against. What is the percentage increase? You could do an average of, say, 5-year average, 3-year average, whatever of prior pre-pandemic years. Say that's the excess mortality. However, there was trends of mortality before that. If mortality was decreasing, and it wasn't, well, continue to trend that, and then the change against that trend is the excess mortality. The thing is, by age group, some of the age groups had a bad trend pre-pandemic, and we will see that when we get to cause of death. Maybe we shouldn't do it by, we should trend it by age group, or maybe we should trend it by cause of death. And that's one of the things I looked at, is how have the death rates by cause of death changed during the pandemic. And some of them went up, some of them went down, a lot of them went up. And some of them were external causes of death: homicide, suicide, accidental causes of death. We'll get to those in future videos. But to keep it simple, and because very conveniently 2019 was a boring mortality year, I'm just going to compare it against the same month in 2019, so that takes care of the seasonality issue. And we can see, I mean, a 50% increase is very big. So on the worst months, in December 2020, January 2021, January 2022, and let's see, I believe that's September 2021, we had number of deaths per day, average number of deaths per day being greater than 40% compared to the same month in 2019. And that's huge. I mean, that's great. But even on the lowest ones, it's like 5%. That's pretty big, even for the quietest ones. And we see in the end of 2022, which is what I want to point out, even after we had this collapse. So, like, okay, maybe this is fluctuation or growth of the population in March and April of 2022. For the last half of 2022, we still see a number of deaths per day greater than 10% compared to 2019. That's not population growth. We didn't have a population growth of 10% in a couple of years between 2019 and 2022. That's not why deaths are over 10%, and it's not all COVID. Yes, some of this are COVID deaths. I'm not going to disagree there. But there's a lot of non-COVID increased mortality, and we need to think about that. What's driving this? Can we do something about it? Or what can we do about it? Can we go back to good trends? And in some of these cases, we'll see there were bad trends before the pandemic. So shifting to the next section, let's just look at age group, because I'll be doing a lot of these breakdowns by age group. Age is one of the biggest drivers with regards to mortality trends, and this is the graph that's really going to show you that. Again, we see this scale goes up to 18,000 out of 100,000. So remember, so 2,000s can be like 2% out of 100,000. So this is 2% per year. Let me look at the 85, and we have these 5-year age groups. I do 2018 to 2022. I go from infant mortality, which is less than 1 year, up to 85 plus years. And yes, I could do 85 to 89, 90 to 94, but I'm not doing that because you can see the mortality rates are getting to be really high, and the CDC gets a little persnickety, like, oh, it's insufficient data. It's not insufficient data, but it does get noisy past age 85, and I'd have to use like confidence intervals up here, and then I'd have to use actuarial smoothing techniques, and I don't want to do that. I'm not going to do that, is basically, I'm not putting in that work, because a lot of really interesting stuff, and you can see it already with these, you can visually see this here in the age 70 to 74, 75 to 79, there's these, visually you can see, okay, there's these big gaps. But it's hard to see because this is like an exponential curve when I have a linear vertical axis. Because, for most of the age groups under age 70, it's very small death rates. It's less than 1%. How can I tell how much this is changed? Well, I'm going to be doing stuff like percentage change compared against, again, 2019, and I'll show that in a moment. But one thing I do, and I'm going to be doing this in a lot of the graphs, and I'll keep explaining it each time I do it, is I'm going to switch from this linear vertical scale to a logarithmic vertical scale. And you'll be like, what is this? And why do I do this? Well, it's so that you can see the pattern. I'm doing visual, I'm doing data visualization, and if you can't see it, why visualize it? But there is actually a reason for this. We have something called, Gompertz Makeham rule. It's a frailty curve. I mean, it is an exponential curve. But if we have something that's like a natural cause of death, these people who have gone before us noticed, age is one of the really big determining factors of mortality rates, especially for natural causes of death. And if we graph it on this logarithmic scale, so instead of doing it like every 2,000 that it increases, it goes from 1, 10, 100, 1,000, 10,000, 100,000. So again, 1,000 is a 1% mortality rate. 10,000 is 10%. 100,000 is 100%. So you're not going to see the curve go to 100%, not the way I'm graphing it. So it does weird things for children, but the concept is, under this Gompertz-Makeham rule, is that it would look like a line. Now, this is not exactly a line, but it's close to linear with this logarithmic scale. And the way it diverges from being linear, well, not everything is a natural cause of death. And we'll see, again, in future videos, that some of the most disturbing trends in the pandemic are non-natural causes of death, specifically in the accidental causes, which are natural. The accidental causes includes accidental drug overdoses and motor vehicle accidents, which a lot of people think about. But there's also certain accidental causes of death that have a pattern like the frailty law, death by falls. So we'll see that. But also homicides, death by homicides went up by a lot in the younger adult groups during the pandemic. So we have this kind of pattern. Some of these had a bad trend before the pandemic, specifically drug overdoses. We'll see that in future videos. But again, it's still a little difficult to see. But in this graph, instead of seeing those gaps at the older ages, we see it now in the age 40 to 44, 35 to 39. Still kind of difficult, especially since I made the lines so thick, of what the difference is between our boring year of 2019 and these bad years of 2020, 2021, and 2022. So let's look at the percentage change for each of these age groups against 2019. It's bad. And it's the worst for age 40 to 44. Again, I'm not giving the game away of what's driving this. We're comparing against 2019 again, so that's why 2019 is just a straight line. I'm comparing it against itself, so there's no change against itself. The yellow line is 2018, and that gives you an idea of what normal year-over-year fluctuations looks like. It changes, a few percentages points each year. That's not that different. But the dark blue line is 2020. And, not much going on with children. Remember, they're not dying from much. But in these young adult and kind of middle-aged adult age ranges, there's some really bad stuff going on. And what's interesting, of course, is 2022 looks about as bad as 2020. Now, a lot of those deaths are front-loaded at the beginning of 2022 to the end of 2022, and that's still partial and provisional. This may get worse, actually. So this weird curve for this light blue, it might actually go up as more data come in during 2023. We'll see. But this may come down because fewer COVID deaths in 2022. We'll see. It might be due to, older people getting the COVID vaccine compared to younger people who are less vaccinated. We'll see. 2021 was definitely the worst with regards to COVID deaths, but also some other non-COVID deaths, as we'll see in future videos. So, bad. Now, again, this is relative mortality, 40 to 44-year-olds generally, and we saw, and I'll go back just so we can see it on the linear scale. Here's 40 to 44-year-olds. Where are they? Versus here's your 85-year-olds. Exponential. It doesn't take a lot of extra deaths to really push up it to a 50% increase. So a 50% increase. I mean, you can barely see visually. Let me go to the logarithmic scale. So we can see it here. So here's 40 to 44. On the logarithmic scale, okay, you can see that 50% increase on the logarithmic scale. With regards to, okay, yeah, I can see those very large percentage increases on the logarithmic scale. But it doesn't, it takes a lot more deaths for older people to push it up 50% increase. And most of the extra deaths for old people, of course, were COVID. And certain other causes of death for older people, as we'll see, actually went down because of what was going on. So like motor vehicle accident deaths actually went down for older people, at least in 2020. And we'll see other causes of death that changed by age group. There was differential impacts that even though, like say, maybe the age-adjusted death rate for a certain cause of death overall may have been flat, it may have differed by age group. So those are things that we'll look at in future videos. This is kind of capturing at a very high level things that changed. You may not have noticed this because, again, it doesn't take a lot of extra deaths to have over 40% increase in the number of deaths or death rates for that age group. Not many people die there. And you can see there wasn't as much of an effect for children, and then about a 20% increase for older, for seniors up here. A lot of the increase in deaths were in these kind of working ages and younger adults. And it's a lot of the headline kind of causes of death, not just COVID. So we'll see that in future videos.